Great. Thank you so much, Kasser. That was great. And thank you everyone so much for your lightning talks. Really super impressed with all the work, and super grateful for everyone's work and for participating in Here 2021 and for making this a success. So I'm gonna pass this over to Joseph. I think Joseph had wanted to talk quickly about the PMLR issue that we have coming up, and we invite all of you to participate in, and then we'll get into the Q&A. You still there? There you are.
Yeah, I'm just having some laptop charging issues.
Okay.
These talks were very, very exciting and covered a lot of very interesting ground. And I was very excited for people to raise a lot of open issues that were sort of in the back of our mind, but people really got to get in a nuanced way. We encourage everyone to submit to PMLR. We're still trying to figure out about pushing back the deadline a bit. People have asked for a little more time so they could really put something together. I just need to confirm with the other journal editors that the timeline works for them. This was brilliant. I think perhaps we might just start a very low chit-chat mailing list for people that are getting involved to discuss. I'd like to actually put together a summary, and maybe other people can summarize what are some of the interesting open questions that they didn't get to. We might even find some sort of collaboration for people that want to try doing different sorts of ablation studies so that we don't have to reinvent the wheel. So I'm just very excited about the PMLR paper because I think there's a lot of these interesting open questions that we can dig into. This has been for me such a wonderful challenge and collaboration. Since the beginning, we've really tried to avoid the word of competition, and we've thought of this more as a mere exchange where people are really coming together and sharing so that the field as a whole can grow. With that, I want to just turn everything over to Q&A. I think we have Jordi, do you want to moderate or should I?
I'll just share my screen, but if you want to kick it off. So I'm just going to share a screen for everyone, just so we get a list of all the speakers and the titles, so you have a reference for any questions. Yeah, but if you had any questions to kick it off, Joseph, otherwise we can just kind of turn it over.
I saw one in the chat. Just trying to.
Oh, I wanted. Okay.
Yes, I'm just trying to pull up my. Sorry, does anyone else see the chat? There was a really nice question.
I think John, you had asked a question to Heinrich. I'm not sure if you want to just ask that over Zoom.
You can just repeat the question and we can discuss.
Sure.
Heinrich is maybe more relevant to answer.
Great. So I'll just repeat the question for everyone. So the question was to Heinrich, to understand your pooling approach from the 7x7 output, you first do aggregation, mean, across the frequency dimension and then across time. It'd be very interesting to see a one-to-one comparison / ablation with the global mean to see the effect. So comparison / ablation. Do you want to jump in on that, Heinrich?
Yeah, sure. So the point is, so first of all, yeah, it's mean pooling. Second of all, it's not a 7x7, right? I mean, for images, it would be 7x7, right? But for us, like the downsampling factor of these like standardized neural networks are usually 32, right? So that means like I get some input of t, like length t, like you know, whatever, like 1,000 frames, and then it subsamples by 32, right? I do the same, of course, by a frequency dimension. In my case, it's actually like I use 64-dimensional like Mel spectrograms, and so it gets to 2. So at first, like subsample, like in the frequency dimension, like these 2, I just first average, then go over like a sigmoid, like get for each for each time step, I get like some classification output, and then average them, and not doing so. And like for the other question, I mean, just I guess that is maybe a clear, but a one-to-one comparison, like on the DK set, I didn't do, but like I noticed this behavior. So like in So when I usually train like these kind of CNNs on audio set, and like for that's why my talk was called practical reasons. So 10-second long training and then 10-second long testing is a very unrealistic scenario. So what I mean by this is like no person in the world will maybe like wait for 10 seconds up until you tell him, hey man, there was like in the last 10 seconds that was like this and this and this, right? So you would usually like have a shorter time resolution. And I noticed that when I do like a global average pooling over time and frequencies, that even though like it still works, everything is fine. But if you do that and like you input the model like a smaller time resolution window, like 1 second or 2 seconds, the scores that are generated there are like far lower than it should be. So I was suspecting that it mixes up some like time and frequency information. So yeah, that's why I did the whole thing.
If I can jump in for 15 seconds, I mean, this raises some very interesting open questions from the competition that we don't have solved yet. And I would love for us to make progress on this. The first is, how do you actually embed audio clips that are of different lengths, whether it's 30 seconds or 1 second? And second of all, when you do sort of an average pool, you tend to lose all the temporal structure over time. And what I thought was very interesting for yours was that emotion recognition typically involves a pitch contour over time. But if you do a mean poll, you kind of actually lose the order in which inflection and tonal inflection happens. So that might have been another reason that yours did so well on that, which I thought was quite interesting.
I would also like to maybe add, like before in the talk, like I think who was it? Like Logitech AI? Yeah, like it was Gasser. Gasser said like before that maybe that stuff like audio set pre-training, so like maybe works well because the model sees like a lot of emotions during the training. But so maybe that's a valid point, but like on the other hand side, it's also like why does it then like fail for like language recognition? Because there's a highlight. I mean, it's overwhelmingly in English audio set, but there's also other languages, and like they are not very consistent. So you should be also maybe able to pick that up, isn't it?
Any other immediate questions, comments that people have?
Yes, I would have a question. Can you hear me?
Yes.
Christian, concerning the vision transformer solution. So I was wondering, you are doing patches in both directions, so in time direction and also frequency direction. And I would think that normally you could use the whole frequency axis as an embedding vector and then use only the time direction as a sequence. So I'm wondering, I think what Heinrich said, it's maybe very problematic to mix up these two dimensions by using these patches. So maybe you can comment on this, why you are doing this.
Yeah, so what I noticed from like playing around with the transformers, they're like very very strong to overfit. So and they are really hard to train. Even on images on ImageNet, like Google, they use like their private data set, to train the vision transformer. ImageNet and Facebook, they use like very aggressive data augmentation. When I try to train them from scratch on audio set is not enough for them to in my experiments to reach this performance. So that's why I start from a pre-trained model. Started from Diet, the one from Facebook, pre-trained on ImageNet with a lot of augmentation. I also tried the VIT Huge from the original Vision Transformer paper, and they both reached the same performance that I report in the paper. So regarding to your questions, yeah, it might make sense to do what you do, but we have to find maybe a way to use the pre-trained weights from the transformer.
Okay, I see, because it's not enough data to train the transformer model.
Yeah, this is what I found from my experiment. Unless like there is
No.
some new like data augmentation that might help, like Facebook they did in the diet on images.
Okay, but that means you used the pre-trained vision transformer, pre-trained on ImageNet or
yes, that gives me like
for this audio. Yeah, okay.
Yeah, not even bigger than ImageNet. So the VIT was trained like on a private data set, I think millions. And, yeah.
Very huge data set. Yeah. Okay. Yeah, thanks.
Can I add a question on just again on like the transformer stuff? So how do you do it like during testing? I mean, during training that you use patch out and like that increases the speed and performance, that makes sense. But so during testing, you don't do patch out, do you?
No, just like a dropout.
Okay.
Yeah, I use the whole sequence. So the performance gains are only during training.
Okay, because I thought like that, you know, it would be, I wouldn't say like interesting, you know, but like this, when you just randomly then just like feed it, you know, just drop it out during testing, and then it, of course, obviously also will improve speed, but does it also reduce performance, right?
Well, yeah, I mean, in general, the memory requirements is during testing is not an issue. You know, my main problem was we have this 2080 Ti with a small memory on our like compute our resources, and I mean, you need like a lot of them to be able to train the transformer. But during testing, there are some works about fast transformer, which they can approximate. You don't have to do like the whole sequence. There's like faster algorithm to do it during testing. But yeah, I didn't go into that at all in my work.
And just very quickly on this note, I also want to say yet again, you know, here is about knowledge exchange, and here is about the community growing. When it comes to PL-MALAR, you don't need to submit exactly what you did for NeurIPS. If there are improvements, if there are refinements, if there are ablation experiments that you want to do, we highly encourage this. This isn't about saying you are the one best winner. It's all about us learning from each other. So.
I actually had a comment about what Heinrich mentioned. When we were talking about the idea of why it would be working, like why would a model be working good with emotion recognition, and in terms of like language, also like the audio set had maybe other language, but maybe English biased. So that's a very good question to investigate and get a more logical intuition to it. But from an empirical point of view, like empirically, we have seen that when we tested the model that is pre-trained on audio set on different languages, the variation of the language and the different and the difference of languages was not a huge impact in performance. However, when it comes to like emotion recognition, that was very obvious, and it captured very well from the audio set data set. So it's basically, it could be sort of, the language wouldn't have, maybe the language doesn't have the same impact as other features or as more paralinguistic features that we're trying to capture. So it depends on what kind of features the model is learning at the end. Is it related to more linguistic stuff or more paralinguistic stuff? So that can actually show why, regarding the language part, it was different.
Other questions, comments?
Yeah, I have one question. So it seems like in most of the entries here, you either use like global average pooling, or you have some attention mechanism, and so you're sort of honing in on some temporal aspect. If you, has there been any work on using like exemplars or some sort of like time warping here to learn some sort of actual time varying representation of an audio clip? So instead of it attenuating to a given time point, maximal time point, or whatever. And there are many different ways of doing this. You could think of an exemplar-based approach on embeddings using dynamic time warping or something like that. Like something like that exists, or has there been recent work there?
So I would defer to the team members to see first what they thought about and their perspective on that. We as organizers have also thought about this, but I don't want to I don't want to jump the gun. I want to hear what other people have had to think about this, really.
Might I say like just one comment to that right now, Colin? Just when there's also like other challenges, right? Like for sound event detection, for like when you want to like precisely know some timestamps, right? And usually this is like one of the more neglected like how to say, like challenges, because it's in practice, of course, not very important. That's just like my comment to it. Just how to say, like it's actually a bit more important to have like a scene embedding than to have like a very precise. It doesn't matter like how we do that, like exemplar wise, like as you said right now. But just what I want to comment on is, yeah, in practice, I think just like scene embeddings are important.
Mm-hmm. Yeah, and there are definitely different use cases here that I can imagine. Yeah, like where they may.
And I will say that we endeavored to have scene embedding tasks where the temporal order is not so important. Like if you're listening to music genre, it doesn't really matter what order you shuffle it, it's probably jazz. But then on the other hand, we also have had some tasks where the temporal order really does matter. And Crema-D and later emotion recognition work say it's actually about the pitch contours, not the average pitch over time, is more indicative of what the emotional arc of that sentence in that utterance is. You know, another example is vocal imitations. Vocal imitations is there are 300 sounds in audio sets, and humans came and they tried to do query by voice. And in that case, the temporal structure of these audio set files that could be between 1 and 10 seconds long, you want to have a tag early on, and you want to actually to match the temporal structure. So besides capturing timbral elements, just having the temporal structure inside your fixed length embedding can help you a lot of doing the vocal imitations task, as another example.
Yeah, I think those are great examples. That's another reason why this is such an incredibly hard task, right? Because like some of these tasks, that's really important. Other tasks, it couldn't care less. Thanks.
I'm just seeing there's another question in the chat from Ilias. That fusion and concatenation is an interesting work. Does it work well for event localization, detecting an onset and an offset?
Hello, can you hear me?
Hey, yeah, we can hear you.
Okay, I'm Tony, and I would say yes, that event localization and detecting an onset and offset is like the task of decades, right? Or related tasks. And we find that especially feature fusion, the fusion of multi-level features can performs really good in terms of event localization. And we also have these experimental results, but we did not show up in the slides during the presentation time. But we can say that the fusion techniques for multi-level feature aggregation is a very good skill for event localization and detecting an onset and offset. Yes.
And just to chime in, you know, that was one of the reasons we thought your work was so exciting, because your fusion wave to that, for example, even on speech commands, was much better than plain old last layer wave to back that we did. So
yeah, but can you repeat your questions?
My question or my comment?
Oh, your comments.
Oh, so we had a wave to back that was just the last layer. And then you had a fusion wave to back that's all the layers. And your fusion wave to back did even better on speech commands than just plain one layer of wave to vet. And that was like, for me, like, great, we see where the fusion helps.
In terms of this, like speech comments or speech recognition tasks, because the original SSL models have had a great performance on these kinds of tests, because these kinds of these kinds of SSL models, such as Wave2, VEC2, are trained in speech-related data set like LibreSpeech or Google Comments. So they originally have had a good performance on this kind of tests. And after using the technique of fusion, well, in most cases, the accuracy will be a little bit higher, but it's not very obvious, because the original accuracy has had been high enough. But we will say that fusion is still a good technique. It makes models perform better in most cases, in most tests. Yeah.
You don't need to pull up the leaderboard right now, but Wave to VEC without fusion is getting 88%. And your fusion Wave to get is getting 97%. That's a 10% accuracy increase. For me, that's big. So it's not always it's not always just peanuts. Sometimes it can make a big difference.
Yeah, we should spend some time on this kind of phenomenon. Yeah, we may be talking about these kinds of results in the longer paper in the future. Oh, by the way, I have questions for Logitech AI. And my questions is that you say that you use Boyo or Boyo, right? A paper released in last year. So the technique used in Boyo is that you have to split the original image into maybe 2 parts or several parts, and you use models to process the feature, and you're trying to make the 2 splitted part of the image to fall in same or very close feature space to learn the feature representation of this kind of image. And you say that you split the audio, because this is the challenge. This is the case of audio. So you split the audio by their time, like 150 millisecond audio. You can split them into 3 parts, and each part is 50 millisecond audio, right? And have you ever tried other kinds of splits, like split them in terms of the feature? Like originally maybe one timestamp will have 1,000 feature points. You can split them into 500 and 500 feature points. You can split them from different aspects. Have you ever tried this kind of experiment?
Yeah, thank you for your question. So just to make sure I understood it correctly, so when we talk about the training paradigm itself, like to take 2 copies of the input, we basically don't split the copies. It's the same input, and you just create an augmented version of it. So basically you randomly add mixed audio in the background. So it's basically different backgrounds now. You have 2 copies with different background, but the same foreground. You kind of do pitch shifting and time stretching, and they're randomly done. So it's basically, you have two different copies from the original input, and then you kind of force the network to learn, like to project the data that have different augmented views but are similar, but are the original. They came from the original input, to close embedding space. So this was the idea. So basically we don't split the audio itself and then take different parts of the audio to the both networks. So that's in terms of the training paradigm. When we talk about the timestamp part, the timestamp is just the thing that we were worried about is that we don't know if Biolas would actually work on very small windows of audio, and we haven't tested that yet, and it's something that we're considering. So that's why we were playing it safe, as you would say, that we would take the window that it was trained on already. It was trained to take a random 1 second from the audio clip and then create the two augmented views. So basically we would take the 1 second and then move it with a hop size of like even 50 milliseconds. That shows that there's a huge overlap for each window. But the reason that we also wanted to follow a guideline of like, it was recommended that not to exceed of 50 milliseconds for in case of music transcription tasks. So that's why we kind of created this set of parameters and said, okay, we're gonna roll the dice here and see how it would work. And then from there, we're gonna do further experimentation. But if you're talking about training with different splits and of the audio, the reason actually Biol doesn't depend on that, because previous models would actually try to check temporal proximity of the audio. So basically they would project on the embedding space the audios that are temporally closer together and with the positive pairs and the whole negative pairs thing. But the problem with this that Biol actually says that in some cases this would fail, and we don't want to rely on temporal proximity. So we're going to rely on the whole augmenting the whole audio and just trying to learn as much as possible like robust features from different augmentations. And that's the difference between Biol and previous and other models, and also the way we performed it.
Thank you.
Thank you.
And yeah, just one more quick follow-up. Yeah, so I'm aware of the COLA work by Said and Granger, where they're doing the contrastive learning, where they split the audio into two clips and want them to have the similar representation. What was the failure mode you were saying in that particular setup that you want to avoid?
Yeah, so they mentioned it also in the Biola paper. It was like some scenarios, for example, when we talk about music, so you have repetitive sequences. So basically, if you're talking about a specific segment, it could be repeated again on a longer or a more remote segment. So basically, if you're just working on the proximity part, on the temporal proximity, it's not going to give efficient results because it's actually the exact same sequence being repeated as a rhythm. So that would be a case that it could fail. Another scenario that it could fail in case of very abrupt sound events, like for example, a shotgun or a door knock. So if we said like there's a door knock that followed with footsteps, so they are very close to each other. So they would seem that they should be in a close embedding space, although they are two different events, sound events. So that was like two different examples that they mentioned in the Biola paper that actually claim why the Biola is looking for something more than just temporal proximity. I hope this answered your question.
Yeah. Just to quickly jump on a question on the chat, Hosiang Wu asks, are the evaluation suites for the secret task going to be open source release? They can run follow-up experiments. This is of the utmost importance to us is reproducibility. And for that we're not just talking about like, oh, go download audio, so go download VoxLab, spend hours scraping YouTube. We're really looking for one-click downloads where everyone has the same exact splits. We'll be talking about this afterwards, and we just want people to reach out to us and explain to us what sort of timeline they have in mind. The current data sets, I mean, we can click upload tomorrow, and it would be good enough for us to get everyone started. The final data sets, we just want to make sure that everything has the same timestamps, everything is perfect. So if you wanted to get started immediately, just let us know. And we want to do a formal release where everything has the exact same timestamp, and we're like, this is the exact thing that everyone is using, as opposed to a mix of data sets that that we haven't run the pipeline once start to finish. We ran one at a time, and we just really want to ensure everything's consistent. So it really depends your preference. Do you really want to get started and then get the final things later, or do you want just a big dump of everything? But these data sets are forthcoming, and it is the mission statement of here to make it very easy for anyone to do this. Even to the point that we have defined standard k-fold splits for a lot of old tasks that have not given k-fold splits, you know, so. Questions and follow-up, feedback. Well, I guess that might be everything.
Because it looks like there's one more
Oh.
question in the chat. Are you open for suggestions for additional data sets / tasks? In new case, I would nominate anomaly / novelty detection tasks such as DCase 2021, task 2, or maybe audiometric learning similarity. Yeah, totally. I think that's one of the things we had been talking about is sort of like similarity, wanted to get into some sort of like perceptual distance stuff and just didn't quite get there, focused on classification stuff. But absolutely, definitely open for suggestions on future tasks and that kind of stuff. So
yeah,
yeah.
So
like specific stuff, shoot us an email. Would love to hear more.
So first of all, we are definitely open to other tasks. One thing we've actually done is we've gotten these pre-processing pipelines that for most data sets in like 30 lines of code, we can get it in a completely normalized format with different sample rates, and you can just download the data set, and in 15 seconds you are totally sure how to run it, which we hope is something that people run with. Let's talk about other tasks, whatever you have in mind. We're open to hearing it. In terms of new timestamp embedding tasks, these actually involve so many more design decisions that we do feel like sometimes it can be hard for us to do apples to apples comparisons. And they also tend to take so much longer to train. So our preference is not to lean in more on these very long timestamp embedding tasks. But if you want to do it, we're open to doing it. We might actually have 2 tiers where you only do the seed embeddings. And if you want to do the really time-intensive timestamp embeddings, you're welcome to, but it's not required. Audiometric similarity and learning. In particular, there are 1 or 2 very interesting tasks that we weren't able to get pre-processed in time, but we really want to do, particularly tasks where the audio distance should be highly correlated with human perception. And that's something we really think is important, is missing. And we're also open to other ideas too. So we're all ears.
The final question, will there be a Here 2022 challenge?
Yeah, that's a good question. I think it really depends how the community responds.
Yeah.
If, you know, I mean, I was talking to Jonathan, he was like, Joseph, like, if you get 3 submissions, that's a win. And we're very, very happy with how people submitted. Neil Lawrence at PMLR is like, we know this is pretty specialized and we don't care if you don't have many submissions. Turns out it looks like we might actually have more submissions. I guess the main question is impact. If people think that this has impact and its value, then it's much more enticing. And the goal is to create impact and to really help the community, and it hinges on that. Should we talk about hairs quickly, or is that a total grand diversion?
I don't know, up to you. Has anyone seen that? The hairs evaluation.
Yeah. We could skip it for now. But there's very recently proposed a audio evaluation benchmark suite that is called HAIRS, Holistic Evaluation of Representations of Embeddings. And I guess the main difference between this HAIRS competition that was recently proposed is it involves, it doesn't really lead in on replicability. Involves a ton of data sets that are very hard to obtain. We think that that kind of creates a lot of friction for people to actually just get out there and run the numbers in a very broad sense. So if people adopt here, that is the important thing. Oh, and John, one more thing. You were asking which of these numbers are directly comparable to the literature. I think we put it in the leaderboard, but we've endeavored that there are a handful that the numbers, even though the shallow training regime is a simplification, the numbers themselves are actually directly comparable to the literature. So.
Great, thank you so much.
Thank you, everyone.
All right, are there any final questions, comments? Really appreciate everyone staying tuned, and yeah, really impressed with the lightning talks and all the submissions. This has been really great. Really appreciate it, everyone.
This was really wonderful. Thank you.
Yeah, bravo, and congratulations to everyone who participated.
Yeah,
really great work. All right, well, I think we're going to wrap up, and yeah, so stay tuned. We'll be sending out emails. We'll let everyone know when all the secret data sets are released, and more information about the PMLR, so stay tuned.
Yeah, I think we might just start a low volume mailing list also for people to do a little more detailed chit chat.
Yeah, that'd be great.
Yeah, so.
Okay,
great.
I think I'm gonna finish it up. All right. Okay, take care, everyone. Enjoy the rest of NeurIPS.
Bye, guys.
See ya. See ya.
Thank you so much.
Bye.